Alrighty, it's time to do that countdown time again. Yes, making a camera cage with the 1/4 inch mount for the YoloCam S3 webcam with Tinkercad. We're going to print out, actually I have printed out a number of, I guess, examples, proof of concept, fine tuning, I don't know, whatever the hell the word is that you use when you print out something that you're trying to make and you have different versions. Put it in the comment section if you know what that is. Anyway, I'm Steve, retired hobby tech guy living here in Korea, American expat. And so I'm doing stuff besides making videos and I got some pretty cool stuff. I mean, you look at the background here. I got some cool background here. We got George pops back in, says howdy. If I take a look at this camera, I got the red. Ooh, pretty cool. But what I ended up doing is making a camera cage and mount for this camera here, which is the YoloCam S3. And the YoloCam S3 is a pretty nice camera. It's a web camera. It's a USB-C connection on the back, as you can see there. But the problem with this mount, and the mount's pretty nice. I mean, it kind of does that little thing there. There's a 1/4 inch 20 on the bottom of that, which is great. So you can raise and lower and tilt and all that good stuff. But yeah, it's magnetic, and that's the problem. We got George says he says, sorry, I missed the stream earlier. I'm busy at the hospital. Oh, I hope everything's okay. We had to stop by the hospital yesterday. Matter of fact, I had to drop off a prescription and I got to pick that up later. But yeah, hopefully everything's doing okay with you, George. Going to the hospital isn't something that, you know, you go on a whim and, hey, what do you want to do today? Oh, let's go to the hospital. Yeah, that's usually not the way it works. So yeah, I hope you're doing well. Yeah, hang in there. Or whoever's going to the hospital, hopefully they're hanging in there as well. Hopefully it's not serious. Everything gets cleared up real quick. So anyway, with this YoloCam S3 webcam, it is awesome because I use it on the paint station. It has got excellent autofocus. You know, you bring things up to it, it quickly latches on. I really like this. Matter of fact, I ordered another one for a top-down view. But the problem is that the cable gets connected onto the back right there. And if you move the cable, it will kind of move because it's just a magnet. I mean, it's just, you can put it back there up against that stop, but it just, anytime there's any type of movement, and it's not like it sets into an inset to keep it from rotating like that. I mean, it can really, you know, just a little bit of tension can move that. And then when I move the camera arm that this is on, when I move the arm around, that pulls the camera and it messes up the seating on this. So you can see you can get some pretty, it's just too much movement. So I decided, you know what I'm going to end up doing? I'm going to go on to Tinkercad and make a mount with a 1/4 inch 20 female end on it to, boom, put a camera mount on it. We got Terry. Terry pops up, says morning. Good morning, sir. Yeah, we're back. We're doing a little bit of a cage mount thing in Tinkercad. And so let's just jump into that and I'll show you what I'm talking about. So here we are in Tinkercad, and here is the mock-up of the YoloCam. And so we got the dimensions there. All I ended up doing was, you know, getting the calipers, taking a look at that, boom, and, you know, putting some little rounded edges on there so it kind of meets the same footprint as the YoloCam, which turns out pretty good. So then what I ended up doing is going through a series, as we can see, a series of different attempts or prototypes. That was the word I was looking for, prototypes. So for example, on this prototype here, what I would end up doing is taking the YoloCam and slide it in from the top. And so that way it just kind of, boom, it sets in there. it's good to go. And then we even put a hole on the bottom in which we could put a 1/4" 20 female end on there. And if we actually take a look at this, let's get out of here real quick. This was what I ended up doing. So I even put the 1/4 20 in there with my little handy dandy soldering iron thing. Worked out great. I needed to up the infill on this, so I'm going to have it at about 20-25%. But as you can see, which it just slides right in there, and boom, you're good to go. Now it does kind of move around. It does stay in there, but it can pop out. So I wanted to do something. This is just one version. So for like a side-mounted, camera view on the camera arm, it holds it in there. There's a little bit of movement. So I was like, hey, let me just get a little bit of a piece of cork or tape or whatever, and then it holds it in there. That was good enough. And then I was like, well, let me see if I can do something else. So I moved on to the next iteration, and I wanted to fully enclose the camera inside of the mount. So what we ended up doing here, if you could take a look, we took and added a little bit more. And the first version of this, I didn't have the little shelf down here. It was just all the way run through. But what actually happens is that we go like so, and we've got the little joint there, and boom, that slides in there, and that should lock that in. A lot of playing around with that, doing that little carpenter's joint there. I forget the name, the official name of that, but it took a couple trials and errors, and I first did it on the Creality print slicer, because you can slice the model, and basically what we ended up with was this right here, and there it is, and you can see it's got there. But the problem, and it went all the way through to the bottom, but the problem with this is that it didn't have enough material. See how thin that is? And the problem is painfully obvious. So it just, and the clearance on this joint is a bit too loose. So it was kind of like I took it back, I took it down to like 0.1 millimeters, but I mean, it goes on there, but it's just kind of, it's not tight enough. And I wanted to have a stop along the bottom. So that's when I figured, you know what, I'll just leave a shelf on which that could go. So that's what I ended up doing with this one here, is taking the whole thing, taking the original one there, and taking the original housing there, and then kind of blew it up, drug it out, did some remeasurements and stuff like that, and then put a little shelf there, so that way this would be able to slide in and you'd have a stop. Hopefully we'll see what happens on this, because of the clearance that I have on there is hopefully going to be 0.1 millimeter. So hopefully that will give a little bit of resistance. And then this is the one that we printed out right now. I also went through and made a couple different ones with the teardrop design. So that way you wouldn't need any supports on this part of the model, on the front face of that with the teardrop. So that's something. And then I thought, well, let me try something else. It looks a little bit more, you might need some supports on there, but something that looks a little bit more classy, I guess you could say. So we'll see how that works out. So right now, out of these four, this is the one here that we printed out. And I also did, this was a previous version, which is kind of previous version to the one we just printed out. And what we ended up having is, you can see that there. And we got the little dovetail joint there. That's what it was, a dovetail joint. We moved the hole for our 1/4" 20 insert, and it still moves. It's definitely thicker And so I increased the number of walls to 3, and then I think I increased it to like 15 or 20% infill. So this is pretty solid. And this, when we put this in here, it is tight. But it fits in there perfect. And then we can go ahead and put in our slide, and it encases everything, and it's good to go. And we got that 1/4 hole in there. We got some holes in the bottom and on the sides and on the top for venting because it gets a little warm. But I still didn't like that this was, you know, so loose. So that's when I decided to go back and put that shelf on there that we saw previously. So we're getting closer on our prototypes. Come on out. So the only thing that is hampering us is just adding that little shelf. So we'll see how that ends up going. But that one is a pretty good one. This one would work with just the slide in, but we just finished printing. We just finished printing, and so what I want to do is I want to go to the printer. It just finished just prior to this video. So let me go ahead and grab that and bring it in here, and we'll take a look. So yeah, we've got a 3 hours and 13 minutes, 60 grams of material. And we'll see how this goes. So there it is on our golden plate. Got a little bit of tree support action there. And this should work out well. Should. Should and what actually happens can be two different things. So, and I changed some of the settings for the underside. I did 0.25 for a top Z distance, and then I did a honeycomb for the interface layers. Let's see. I did some other stuff, but let's see how easy this comes off and see what our underside looks like. And so you can see we got a little bit of a, we did a honeycomb instead of a regular rectilinear. And we can take a look at the underside. If you can see that, if I can tilt this in the, so that underside is pretty darn good, as we see right there. That is nice. That is really nice. Okay, apparently those settings worked. And we'll take off the supports. And we just did tree supports. And we've got our hole down on the bottom for our 1/4, which is, I think it is 7 millimeters circle. And then that way, what ends up happening is when you put in your 1/4" 20, which is like 8, do the measurement, you always go like a millimeter less, and then that should give you enough material so you, when you inset that with your soldering iron, you should be good to go on that. So we will see how this goes. The other thing I thought about, that I just thought about now, is I could make this with the pre-supports on it, kind of like what we did with the other things for like the paint racks that I did, and I put those automatic supports on there. So what we're going to do is we are going to use our ultrasonic cutter from Hozo, and this thing has been awesome. I realized when I did the review, after this video is over, I'll put a link in the description box, but this thing has come in handy, extremely handy. The more I use it, the more I'm like, you know what, this is pretty nice. So we're just going to kind of go through and cut some of these supports. We can free up some of our see if we can't get this going. But this ultrasonic cutter, I'm digging it more and more. So let's see how this turns out. For the underside. Ooh, that underside's not bad. So yeah, the more I use that ultrasonic cutter, the Neo Blade from Hozo, the more I'm liking it. George ends up saying, you're getting way more use out of the cutter than I believe you originally thought you would. Yeah, I actually am. It is, you know, not only with miniatures and stuff like this, but stuff like this to be able to cut through and to get all this stuff out, it is pretty nice. So I got a little bit of cleanup. But with that, I mean, not that these really need cleaned up, but this makes me think about doing my own auto supports on this, and I've already got some ideas for that. So I can make these edges even better. See, it's right at the top, kind of like right there is kind of fugly looking, but the rest of it is really, really good. And kind of like if you can see there, that's a pretty good top there. So interesting. But this thing has been great. The more I use it, the more I like it. And if you watch the review video, you will know that I wasn't really expecting that. You know, I thought it was a little bit too expensive, but I'm using it more and more, and I didn't think I'd be using it that much. So now, hey, we got Swedish Forges back. He's throwing a little peace sign out there. So now we have this piece there. That is going to be our back plate. And that turned out pretty good. And then this is the main body of the cage, as you can see there. And yep, we're good to go on that. So there, and there is that. And if we go on the bottom, there's our 1/4-20 mounts, and you can see our top surface on that right up in there is really good. So now the question is, will this fit? Because I did some changes. And ooh, that is, ooh, that is tight. That is tight. But it fits in there. Look at that. That comes out really good. Wow. So now I tried to line this up and we'll see what happens. 0.1 millimeter setting on there. Perfect. Perfect. A little bit of movement, but you know we can end up doing, because it moves side to side, not so much up front. But what we could end up doing is putting a little bit of tape or a little bit of a, or you could probably put it on the front. We could put like a little sticker or something on there, and you know, with some tape or whatever. Man, that is tight. That is tight. It is like, I wanted it tight, and it works. It's not marring the camera or anything. But maybe if I made that back hole 0.1 millimeters or 0.02 or something, just give it a tiny bit more space, but I think this is going to work. I mean, there's definitely enough room for the hole of the lens because I made that bigger, so that's good. And then when we put that in there, it's got the hole for that. Yeah, I think this is going to be good. There's enough. It is like right on the edge. And then that dovetail joint that we put on there, you can see right there, it doesn't, it's tight enough to where it catches, but you're going to have enough resistance to where it's not gonna, even if it's upside down. Maybe that would be something I need to look into, to have some type of catch on this, so that way it's like a hole on one side and then a little bit of a nub, so it kind of fits in there. Maybe I could do that on the bottom there, like kind of like right on that side, on that flat face there. We could have like a little tiny half moon inset, and then there could be a half moon bump out on this side, and then that way when it goes in, it would snap into place. You know what I'm talking about? But this looks pretty good. This looks pretty good. The only thing that I want to try to do is try to add and do my own supports for this, but I don't know how that would work. We'd have to do a couple more. But overall, I'm pretty satisfied. And if I end up doing that little snap, that would add a little bit of cool points there. So we could do something like this. So if we took our model, and what we're talking about here, let's go ahead and we'll move this piece over here. And we want this to be our work surface, and so that way that is on the same plane. And then what I could end up doing is I could get like a half sphere, and I could put it right there. I'm not going to be able to adjust that but I could take this down and make that like 3 millimeters, 2 millimeters. What is that? 3 by 3. And how tall is that? 1.5. So I could do like 1.5 or have it stick out 1 millimeter. Is that going to be enough? 1 millimeter is small. But that could be good enough. Maybe 1.25. So we could take this and drop this in about 1.2. So we could do something like that. And then we could go ahead and set that to 1 millimeter. And then how would we center this? I guess I could just, I guess it doesn't really matter. Because what I could end up doing is just taking this, and I could go like however many from the edge. And we'll do some little adjustments here and And so that way it'll be right there. What's it going to be? Yeah. So like that, 0.1 from the edge, and then we could go back to 1 millimeter, and then we could shift it to the left. Go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We go 10 and leave it on that same plane, and I think we'd be good to go there. And then, no, that's not what I want. We grab that, we'll copy it, we'll shift and do the same thing there. And we'll take this to 0.1 and we'll move this over. And that's good because it's at the same place. And then we'll do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those are the same. And we could join those two together. And that could be the bump out. And then on the corresponding piece here, and I'm just kind of trying to figure out how we would do this. And we would have to make a corresponding circle or concave. And since that's already, so I'd have to click that. We'll make a copy of that. And then we'll have to go out because I want to take that out 1 millimeter. But I need to make, because this is going to be, let me see how this would work. And so I could take that and then move these over to the other side. And make those holes. Join it with that. And then we have our corresponding holes for that. So that way it would be, I don't know if that dovetail will give enough flex to be able to do that. That is going to be interesting. And do I need to adjust the size of the purple, this piece here, and make it 0.1 millimeters smaller? So that way it's got room to fit into that concave receptacle on the other side that we see there, because right now they're the same size. So I'd have to go through and make this smaller. Do I really need it? Or I could put these on this piece here. That's a possibility. So let's go ahead and we'll make a copy of this. Let's try that and see what happens. Take it up 90 degrees. We'll take this up. And what we could end up doing here is run this out. And we could center this on our item. This might be a better way to do this. Of course, I'd have to, let's ungroup that. We'll get rid of that one. And what we'll end up doing is we'll go here. And we could do something like that. And then, let's see. That would be larger. You know what? Here's what we can end up doing. we'll take this, we'll put that there, and that'll make the work plane. And since we have this selected, if we hit D, it'll drop it down to the face of that work plane. So now what we can end up doing, that is on the work plane. And then what we could do is we could go back 1, 2, or let's just go back 1. That would put that as the nub, and if we do the corresponding concave part on the other piece, on the back piece, we make that bigger. This should be smaller. See what I'm saying? I'm kind of losing it. Because this I want smaller, so I go 1, 2. And then the corresponding hole, the concave hole part, I would just go 1. Okay, so I think that's what I'd end up doing there. And so that way, I don't have to worry about that. I would have the hole there, or the bump out there. Let's move this out of the way. And let's just get this so it's right there. We'll go down to 1 millimeter. Then we'll drop this down 1. Boy, that's a big jump. 1. Maybe you should do 2. Now we'll just go down 1. I have a hard time believing that's 1 millimeter. Oh, but it's inset, so yeah, that probably is. So now we could select both of these. We could do our little centering thing, and that is now centered. And then we could, come on, get off of there. We could select that. We'll go up here to top left. We'll make a duplicate. And we could go up here, and we could do the same thing. Ooh, that is going to be big. Yeah, that's going to be a little bit too big. So we need to go back down here. Sorry for all that. And that is 3 by 3. Let's make it 2.5. 2.5. And we'll do this at 2.5. And again, what we'll end up doing, we'll select both of those. We'll make sure that it's centered, which it is. And we make a copy of that. We bring the copy up, and then we'll just make that adjusted to 0.1, and we can put that basically in the middle right there. So now we've got those two little bump outs, and we're good to go. So now to make the corresponding concave on the back, we'll select those two. We'll group those together. We'll make a copy. And then what we'll end up doing is we'll go like that. We'll just go 1 because that was in 2. So this should be bigger. And then what we could end up doing is we will make those the holes. We could take this and line that up. And we'll select that. We'll make sure that everything is centered, which now it is. And now I should be able to get this. And I forgot to, crap. Okay. We're almost there. We're almost there. So see how the hole is bigger? So we can grab the hole and So it should work. So we should just be able to grab the hole like that and left shift and bring that. And since that's going to be bigger, remember we just come out 0.1 millimeter, and that should be big enough to meet that or accommodate that bump out on the main body. And so those are on the same plane. So that's a little bit tight up there, but that's okay. The bottom is good. And we just group all of that together. And so now we've got that corresponding concave. And then we could take this and group that together. And now we have that piece, which should be good to go. And so now we have the bump outs on this side, and on this side, we end up having our little holes there that should work. So we should get, hopefully we should get, hopefully it doesn't bump out too much. And basically what I want to end up doing is I want to double check and see the measurement on that. That's 1 millimeter. So it's just barely. So we can see right there, it's just right there. So it's 1 millimeter. I think that would provide enough. We'll see what happens. Of course, I got those other two holes. I don't need those. So I can clean that up a little bit. So we'll just ungroup that. Select off, ungroup that. And then I could select those and get rid of those. And now, yep, we got everything selected. And boom, we've got our holes. Just like we got there. Alrighty, cool. So now we could print this out, and this will be the 5th version of this as we continue on, and that should be able to connect right up as that slides in, and we should be kind of like that. It should just like chunk slide right in there. Well, right in there. So yeah, that's what we're trying to do. So I think we'll print another one of those and see if that works. But with what we have now, definitely what we end up seeing is this is good. This will work. I think the snap on there with the little bumps and everything into the receptacles will add a little bit more of a positive engagement. And I mean, this is tight, but if you think about it, if I put this out for other people to print out, they might have a little bit of a different tolerance with this dovetail joint. So it's not super hard. It's got some movement in there, but there might be a little bit of variation depending on the slicer and the material and the variables of your printer, yada, yada, yada. But this would work fine for just a camera in this position. But I would just want that, you know, if this is like hanging like this, I would want that little extra snap in there. And maybe one snap would be good enough. We'll have to print it out and see. So anyway, that's what we got going on. I'm pretty excited about this. And again, we'll put a 1/4 on this. I could actually do this. We could pull out the old hobby machine And we can do our 1/4 because I think I've got an open plug. Yes, I do. I have an open plug. And I would need a 1/4 insert for this. I think this will be good. Is this going to be long enough? Basically, this is a soldering iron, and it ends up, it's on a little thing, and we've got a little stop on there that you can adjust right here. And then, of course, it's got a little protective sock on there. And then that way you can heat up your soldering iron. You can put the insert onto the model and then drop that in. So that's what we're going to end up doing. I think we could even... I don't like the fact that these things don't have a long enough cord, usually. Okay, we got it plugged in. Let's see, can we get a different camera view on this? I think we can. I wasn't planning on doing this, so if you're kind of like, man, this is unprofessional, you'd be like, yeah, well, it is. So you do something like this, and then that way, what we'll end up doing is we could have and line up our hole, and we could get our 1/4, and what we'll end up doing is, this doesn't have a real good focus either. Well, it does, yeah. But it's got the little 1/4 there. That'll be the end that will go onto our model. And again, I put that hole at 7 millimeters, so it should be good to go. And we will start this thing up. Let's see, we've got a little gauge on there, 350. And what I might have to do is a little bit of just bevel that out just a bit. And so that way we can just get that in and just kind of get that seated in there just a bit. But as soon as it heats up, so you can see what we end up having there, it just kind of seats in there a little bit, and it'll be good to go. And then once this thing heats up, oh, you know what I can do? Is I can do a little bit of digital zoom action. And we can actually check this out. And as that starts to go in, you just drop that down, and boom, we're good to go. So now you can see we've got our focus. We've got our heated insert. This thing will focus. Focus, there we go. So you can see we got our heated insert in there, and it is, can we go down just a little bit more? Yeah, perfect, perfect. So we are perfect on that. Okay, cool. That worked out well. Nice. So now, this is all coming to plan. All coming to plan. Make sure that's not anywhere to start fire. And the other thing you could end up doing with those heated inserts, they're just 1/4 inch, you know, and the reason I'm using 1/4 inch is because on most camera equipment, you're going to have a 1/4 inch 20 on there for cameras, DSLR, handycams, webcams, things like that. Even on the bottom of this mount for the YoloCam, you're going to have a 1/4 inch 20 there. But again, like I said, the magnetic mount here, the camera moves around too much. So what I could end up doing is putting my 1/4 inch 20 and we could screw that on there and boom, we're good to go. So now I've got the mount that I could put this. This is a specific mount. I forget the name of it, but it's a quick release mount from, what is it, newer? F38. Now I'm wondering what it is. So, because somebody's going to ask, F38 quick release. And if we take a look at this, boom, there it is. So the YoloCam F38. So that's it right there. So you've got the top part, you've got the bottom. It's a quick release mount. Those things are really, really nice. And ooh, coupon price. Do I need any more? Maybe. Maybe. Yeah, I've purchased it 4 times. The Pro, there's really not much difference. I've got a Pro, I've got the regular F38. Both of them are compatible. It's not a big deal. But it does have a screw on there on the bottom, as you can see. Right over here, it's got a 1/4 20 insert, and then you could take that out, and then that also allows you to have a 3/8 inch screw as well. So yeah, this is going to turn out pretty good. So that marries up well. And so we can go ahead and we could throw our camera on there. And nope, we don't want it upside down. It's a tight fit. It's always good when it's tight, right? Yes, it is. Tight is good. I don't have a screwdriver. Oh, I do have a screwdriver, do I? Yes, I do. And I just do one final little tweak. And then there we've got that. We can throw our camera in there like so. We slide down our little dovetail thing and boom, we're good to go. So yeah, we'll be able to mount that and that'll work. A little bit of wiggle in there, but I think if you put like some rubberized tape or I don't know, you know, maybe some little rubber strips on there with like adhesive on one side, so that way you've got a little bit of you could actually, where could we put that? It could probably be on the front and we'd be good to go. And so that way you wouldn't get any movement out of your camera at all. So that's what I've been ended up doing. yeah, there it is. So what we ended up, I think it was a pretty good little thing that we did there. Like I said, the next one that we'll end up doing on our prototype is going to be one for that, the little bumps on there. So that way we've got those things on there. George says, dun dun, I'm wondering if you can adjust it with a TPU cushion to absorb vibration. Exactly. That is an excellent, you can make a little TPU, little padding, put it on the front there, and you would be good to go. So you get a little bit, that would take that movement out of there so it wouldn't rattle. And you could probably mount that on these areas like right there. Put a couple little pieces in there, you'd be good to go. So that way it would have contact with the camera right here and here. Probably make it, I don't know, a couple millimeters thick. Put a couple pads on there, maybe 5 by 10, maybe. Yeah, 5 by 10, about 2 millimeters thick. You could put that onto the front there as pads, and you'd be good to go. So yeah, excellent idea. Great, that's a good idea. I like that. I haven't printed TPU on my K2 Plus. I haven't printed any TPU. It's just been PETG and PLA. So we'll see how that goes. So yeah, there it is. What we ended up doing is finishing up, and we're going to do another prototype run. And this one is going to be, as you can see there with that little bump out there and the insert there. Hopefully we'll have enough room and it should be good to go. And then, like you said, if we're going to do some TPU, we could put it like on the areas here and there, kind of like a 10 millimeter by 5 millimeter little rectangle, and that would keep that thing from rattling in there, and it would be good to go. So, we got Ferrithus says, Steve, how's it going? It is going well. We are working on making a cage for our YoloCam S3. So that's what we've been doing. We printed out a couple of prototypes, and it should be good to go. Ferrithus says, you're printing TPU? Fun. Oh no, I haven't printed out TPU. That's just what George recommended. I haven't printed out TPU yet. Concept Gaming says, looks good. Good to see you designing in Tinkercad. It's a great program. Yeah, it's not bad. It's my level, so being able to make a camera cage with a dovetail joint to kind of get that whole thing in there, and then we'll do those little snap stops, little bump stop things in there. Should work out pretty good. And I think we're almost done with that. So we'll print one more, and I'm also thinking about doing the some self-supports for like these circles, so we can try to clean up those top edges, those overhangs there. Concept says he likes a little heat press. Yeah, I'm a sucker for gadgets, and that heat press came out pretty nice. I really enjoyed that. And of course I've used a soldering iron where you just get a tip for your insert, heat up your soldering iron, and then of course if you wanted to do your hole like that, hold your soldering iron pointed up with the insert tip and then the insert, and then just kind of boop, put it on and you're good to go. But I'm a sucker for gadgets. So that, I think I got that off of Amazon, and I was like, you know what? I probably won't use it that much, but I'm using it a little bit more and more. So it's becoming cost effective. So, and it's just nice. Kind of the same thing with this Hozo ultrasonic cutter. This thing has been, I just keep using it more and more. So I'm enjoying it. So matter of fact, I'm under no obligation to do this. This is just, if you're interested in this thing, I don't have an affiliate link or anything like that. But if you're interested in the Hozo Neo blade. You can check that here at the website. Again, I don't have an affiliate link or anything like that. So if you want to check that out, it is a little pricey. They sent me the creator combo, $185. That's, I don't know. I'm liking it. I've got a spare battery, which is nice. But I could do 134. That's probably what I would do if I was going to buy that. But with that being said, since we're going to go off topic, I did just get this from a Kickstarter program for a cordless ultrasonic cutter. I backed this a long time ago. It kept having a bunch of problems, kept getting kicked back. But this is 40,000 hertz, 30 watts, single dose duration more than 10 minutes, 12 volt battery, 1000 milliamp hours, 15 volt, 2 amp charging. So we're going to be taking a look at this. I bought this one off of Kickstarter, so we'll compare it to the Hozo and see what happens. That'll be an interesting video as well. But as it stands, I like this. I really like that. So anyway, that's what we got. George says that cutter might actually pay for itself with as much as you've been using it. I don't know. It's every time I use it, I'm glad that I have it. And the biggest reason that I was glad that I had that thing is when I was making my Necron and I glued them up wrong and I had to do major surgery. I had to cut 2 legs off and cut the miniature off in the middle. There is absolutely zero way I would have been able to do that with an X-Acto blade, a razor blade. This thing saved that character. And when you're talking, for those of you who don't know what I'm talking about, it is a miniature. Let me see if I can find out which one. Nope, it's not that one. Is it this one? Yes, it was this, or is this one, or this one? This one. It is so hard to tell. And well, let's go over to this camera over here. I'll show you what we're talking about. Camera, quick. So this is the guy, and what I ended up doing was having to, everything's opposite day, but I had to cut his legs off, and then I had to cut them off at the waist with that knife, and it's hard to tell because we don't have enough light. Maybe if I do that. But I had to cut his legs off, and I had to cut in the center there where his torso's at. That was crazy because I was tired, I was sick. I put the legs on the wrong side and it wasn't facing the right direction. But it was able to salvage it. And after putting some super glue on there and then priming it, unless you knew that I cut his legs off and cut him in half, you wouldn't notice. That's and when you're talking about a combat team, that combat team costs $170. So you've got, I don't know, divide 170 by however many characters. But I mean, it saved me money on that. So I appreciate that. So yeah, you can't even tell. I mean, I can tell because one of the parts of the legs has a little bit of, it's a little bit of a bump because I used a little bit too much super glue. But once it's primed, I mean, you can barely see it. So George says, Lieutenant Dan, he's got magic legs. Yes, he does. Lieutenant Dan. I still got to do something to indicate that he's Lieutenant Dan. Concept Gaming says that sucks. What sucks is a lot of product on Amazon comes from Temu or China. People inflate the prices and sell them on Amazon. People need to start shopping smarter. Yeah, and the problem is with these ultrasonic cutters, it's such a niche market, they can charge high prices. I've gotten on Coupang, I've gotten on Temu, not that I've actually ordered anything off of Temu, but just did price comparisons. I can't find an ultrasonic cutter that's not kind of within the same range as all the other ones. So I imagine over time these things will come down in price, but as it is right now, they're going to be a little expensive. So, but that thing has saved my bacon a few times already, so I appreciate it. So anyway, that's what we got going on. For those of you who might be wondering how much this little cage guy cost, what we'll do is we'll take a look and we'll pull up the printing info. So we can come here, and so you can see I've done the various iterations of, you know, kind of like that one there. There was another one there, but that one was just way too thin. And then we did some other variations and thickened it up until we got to this one here. And if we want to go over the stats on this, on what I ended up using, we'll kind of do that because somebody might be interested in this. So my little ADHD is like, yeah, line it up. So let's just go ahead and we'll take a look at this. We're using a 0.2 millimeter layer height, and everything else is pretty much stock there. We're using Polymaker PLA black, matte black. We did 3 wall loops. We did 30% infill because I wanted that rigidity with the 3 walls plus the gyroid infill so that it's really solid. So that way if it falls, hits the ground, it'll have some resiliency with that. Everything else on the rest of that is stock. We come down here, overhang speed. Somebody recommended that to me who does a lot of printing, so I just set it at 60 and that's good. For supports, we did tree auto support on the build plate only, 30-degree threshold angle. And then I changed the top Z distance 0.25. And if we take a look, you can see that that top there turns out pretty good. And we did the base pattern in honeycomb. So what I might do when I do the next version is try to go back and do that. Usually it's rectilinear, and that way we could compare the two. Support walls, that was 0. We set that to 2. And then the base pattern spacing, that used to be 2.5. We bumped that up to 3. Top interface layers, I think that was like 2. We put it up onto 3. Bottom interface, we put 1. Not that that matters. When I was thinking about it, interface pattern is grid, and we dropped the interface spacing down to 0.4 instead of the 0.5. So we kind of tightened up the shot group on that interface spacing, so we get a little bit of a better surface area. Let's see, is this the test one? Which one? So, well, these are so hard to tell the difference. But basically, you know, you're kind of looking at an interface layer that's like that. That came out really, really nice off some previous testing. So we did all that. Everything else is stock. We're not using a prime tower, and we did an outer brim on everything. So boom, we're good to go on that. So when we slice this plate up, let's go ahead and we'll take a look. And it's going to be 3 hours and 9 minutes. 63.72 grams, and at the cost that I get my filament, we're talking about $1.34. So yeah, look at that. That is wonderful. I mean, for that right there, to make your own camera cage for webcam or action cam or whatever you want to end up doing, yeah, it took me some time on Tinkercad. It took me a number of hours, few hours to do that. But once that's all done and good, you're talking $1.34. Add on maybe a couple more cents for the insert, And you know, you're still under $2 easy. You're under $1.50 for this thing. So yeah, that's massive savings. So there you have it. What we've been ended up doing is making that camera cage, and we're going to do some other adjustments. We'll see what happens, and other recommendations. Ferrithus says, for these cases, I can really recommend the Creality polycarbonate. Prints really nice and is practically indestructible. Oh, okay, cool. I'll have to look into that. George says, might want to try some ABS because I just got a couple of free rolls. Okay, so ABS. I think I printed out something in ABS a long time ago. I might have some. I'm not sure. And I might have some PET G. I don't know if I ran out of that. The ABS, was that ABS resin? I think it was ABS resin. So, but the polycarbonate, interesting. So what is the big deal with the Creality polycarbonate? What is the big claim to fame with that? Creality polycarbonate filament. Let's take a look at that and we'll see what that does. Materials, polycarbonates. Yeah. Huh? Okay. Okay, that's my wife telling me. Ferrithus says, polycarbonate doesn't stink like ABS, prints nicer for me and is much tougher. Only comes in clear though. Interesting. Okay, we'll have to take a look at that. We will take a look at that. I got some polycarbonate with Amazon, with Polymaker. Interesting. We'll have to take a look at that. Okay, we got to cut this video because we got to go. We got things to do and stuff like that. So just got to start turning stuff off. If you appreciate the video, please like and subscribe to the channel. I would really appreciate that. Anything to help out the channel helps. Again, I'm Steve, the hobby tech guy, American expat, retired in Korea. You can contact me here, email. People bought me coffee. Links in the description box. Again, the best thing that you can do is like the channel, like the video, subscribe to the channel, ring the bell so you can see what I'm doing on the next one. Ferrithus says, I'll send you an email with the link and have a good day. Well, appreciate that. And if anybody's got any other recommendations for filament for a camera cage, shoot me an email and let me know. I would appreciate that. There's so many comments coming in and I'm a one-man band, so I'm not able to do that. Okay, thanks. Got to run. We'll see you on the next video. Peace. Good stuff. Good.